Hey, all you math fans, welcome to the Math Jedi. Today we dive into the order of operations. Are you a BEDMAS fan, PEMDAS, BIDMAS, BODMAS? Which one do you go by? I'll let you in on my little secret, and let's get at it. Here we go. Whenever I do the order of operations lessons, I always want to start talking about the first order, which, of course, if you're a Star Wars fans, you will know what that is. But I'm going to spare you the details of that one, and let's just dive right into it right now. Off the top, I did mention some different key words that you may already have heard from your previous math teachers. And this is something that I find really, really fascinating in terms of what did you learn, or what word did your teacher use when they first introduced the idea of order of operations? Was it BEDMAS? Was it PEMDAS? Was it BIDMAS? I've heard BIDMAS. And I've also heard BODMAS. And this is where I find it really, fascinating. Working in an international school, a lot of my students are from all around the world, and this is very culturally dependent, it seems. I grew up in Canada, and in Canada we use BEDMAS, as far as I know. And this is just a thing. It's like, oh, I wonder why that is. If you're from America, just like literally just below the 49th parallel, you are in America, and that is not an American flag. I do not know how to draw an American flag. I know the different criteria stuff. There's like stripes and stars, right? Doesn't it go something like this? And there's a box, and there's stripes, red. I think red and blue. Is it red and white? Red and white stripes, and then stars. Well, that's a blue star. That's not a red star. Anyways, if you're from America, you are probably saying PEMDAS, which is interesting. And then BIDMAS are for those people in usually the UK, European sometimes. We'll be saying that. And then BODMAS, I've found that a lot of my students from India use BODMAS. So it's kind of interesting. It all does the same thing. So let's just kind of break it down. Here we go. So whether it's a B or a P, and that just means brackets or parentheses. So brackets or parentheses. You always do everything inside that first, okay? So you always do that first. So you're always doing that, number one. And then it becomes kind of interesting because then you start to have the other letters. The next thing is going to be your E, which is, or your I, or your O. Basically, it's your exponents. It's those little things to the power of. You do those next. And those are your exponents. Some people like to use the word indices or index, you'll hear. We have a lot of the same words for the same things in math. And I think the O stands for of, if I couldn't, which apparently. I'm not positive of that one. But anyways, indexes, exponents, most kids get that. Then we move on to always the fun thing, the tie. We have M and D, and that's for multiplying and dividing. I will say this. Divide first. It's easier. But technically, you can do either of them first. It's technically a tie. But divide first, it's easier. There's my big hint for you. And then finally, we're on to adding and subtracting. And that's the A and the S, so adding and subtracting. Oh, we should make that new color, shouldn't we? For sure. Ooh, there we go. I got some cool colors here. There we go. Adding and subtracting. It's also a tie. But for these ones, you want to go left to right. Left to right. Okay, so that's basically what it is. So you got your brackets, your exponents, you're dividing and multiplying as a tie, and you're adding and subtracting as a tie. And when in doubt, you want to go left to right. Did you get all that? Awesome. Let's get into some examples. So say goodbye to that. Oop, there you go. And I'm really digging this kind of aqua blue color. So here we go. Let's go and do the classic. No. So it was classic 9 plus 1 times negative 5 to the power of 2. There we go. We got some different things going on here. Now, this one's always tricky because what I always find is that kids get super excited when they see this. They see this 9 plus 1 and they want to say, great, it's 10. And they go, yeah, I got it. There we go. And they start moving on. No, don't do that. Don't do that. Don't get suckered into doing the easy stuff first that you see right away. Think to yourself, what is the order of operations? And we know that we have to go and do our exponents first. So we have to go and do our exponent first. The bracket's already kind of done for you. So this just means -5 times -5. So remember, this is -5 times -5. A negative times a negative is going to give you a positive. That's right. And all this other stuff just kind of carries down. So you have 9 plus 1 times this. So you have adding and you have multiplying. What are you going to do first? You are going to go and multiply 1 times 25. And then you have 9 plus 25, and that is going to give you 34. I love seeing slashes like that. And we kind of go from there. Let's see some more stuff going on. Let's go and see, we have this sort of thing going on. We have 6 bracket 7 minus 10 divided by 5. We'll cube this one. Take away -2. And I'm going to put a 6 right here. What? That's right. A lot of stuff going on in this one. This is a good one. So right away, we're saying we're going to do our brackets first. Everything inside the brackets. So we're going to have to go and follow the order of operations inside the brackets. So when we get that, we are going to be getting 7 take away 2. And 7 take away 2 is 5. And that 5 is going to be cubed. So remember, we had a 6 out here. This stuff just carries down. And it's so important to keep everything else all nice and organized. Work vertically is always my recommendation. For this, we have to go do our exponents next. So 5 times 5 times 5. Ooh. I think that's going to be 125. I'm going to keep it in brackets just for fun, even though I don't need to, but I'm going to. And here, we get this weird thing going on back here. I'm going to point something out to that weird thing. What is happening between the -2 and the 6? It's a little multiplying. So you rarely will ever see a number on the back end of a bracket like this. But sometimes teachers will. Typically, you see it on the front end like this one. See what I've done here? See the example I'm giving you? To show you both ways. Either way, if a number is stuck to a bracket like this, there's a multiplying sign that is hiding in there. Okay, let's get on to it. We've got some multiplying stuff and some negative stuff going on. We're going to do multiplying. 6 times 125. Oh, just as a quick little mental math kind of thing, this is how I do it in my head. I would say 6 times 100, and I would say 6 times 25. That's what I would do in my head. So that would be like 600 and 625s. That's I think that's fair game. 150. That's going to give us 750. Now take a look at this. Okay, there's still a negative sign here. This is still a negative sign. This is -2 times 6, which is going to be -12. Notice how I'm writing it. Now a couple of things. You do have the double negatives here. The double negative becomes positive. Sometimes I do a transformer sound when I do that, but trust me, it turns into a positive sign. And we get 762 as your final answer. Really good stuff going on with that question. Say goodbye. There we go. Now, let's kick on some other things that I find that always baffles students. And that is brackets within brackets. So here we go. I'm going to have, let's make it super tricky. I'm going to use these square brackets. Now, sometimes you've never seen square brackets before. They're just like regular brackets. We just have them as a square. I don't know. Mathematicians, right? You're all mathematicians right now. So let's go and do some stuff. I can put a dot here. So the dot also sometimes will throw kids off. A dot means multiply. What? Why do these math people keep doing this, right? using all these different signs. Why can't they just figure out whichever one they want? Math is the universal language. So here we go. We've got a bracket within inside a bracket. Here's basically the rule, is you always do the innermost bracket first. I'm going to change that color to really make it stand out. You always do the innermost bracket first. So do all this stuff first. Okay, that's what we need to go and do. So this is going to end up being, what happens here? We're going to multiply first here. We're going to multiply that. So that's, so bracket, this is -5, take away 14. That's what kind of happens there. We're not done yet. We're just going to kind of focus on this bracket right now. -5, take away 14. That's going to be kind of tricky. It's going to be a -19. Remember, if your signs are the same when you're subtracting, it's going to be a negative number, or a positive number, I guess. And let's go and finish off this bracket. Now, we also have something that's hiding right here. What's hiding right there? It's a multiplying sign. I'm going to use that dot again. There's that dot. And that will then give us 3 times -19. Whew. 3 times -19. Mr. Douglas, I don't have a calculator beside me. Well, you should, let's be honest. But right away, we know my answer is going to be negative because it's a positive times a negative. So I know my answer is going to be negative. I'm just showing you how I would think about this. 3 times 19, it's Sunday right now when I'm making this video. I don't want to do that in my head. But if I was going to, this is what I would think of. I would think of 20 times 3. Because that's an easy one to do. That's 60. And I'd say, well, it wasn't 20 times 3. It was 19 times 3. So what am I missing? I'm missing 3. Or I'm missing just 3 off that. Because I did 19 3 times. So I did 23 times. So I need to make that up a little bit. So my answer would be, that's right, 57. So that's how I would do it in my head, just as an FYI. I love mental math. And there we go. That bracket is done now. I know you're screaming like, Mr. Douglas, there's a double negative there. You're right. So that double negative would make it become a positive 57. So let's do it. Second part of the question. That was only the first part. That was just the bracket part. So 57, and we still have all of this stuff to go. So we have -12 divided by 3. And we know that we need to go and divide first. So we're going to take away, what's that, 4? And our answer is 53. And there we go. Let's get on some other tricky stuff. I love showing tricky examples. So you have these. So when you see them the first time, you're like, oh, whoa, what's going on here? And here we go. It has to do with fractions a little bit. And I know, fractions, what are you doing to me? Why would you talk about fractions? Well, fractions are just a part of life. Who doesn't like cookies? What? What do cookies have to do with anything? Well, cookies involve recipes, and recipes involve baking. Baking involves numbers, and oftentimes half cups, quarter cups, and thirds of cups come into play. So, do realize that if you like cookies, you should like fractions. So I'm just going to do this kind of thing. How else can I make this kind of fun? I don't know. Let's do something like that. Whenever you see a fraction that looks pretty complicated, don't worry about it. I see sometimes when a student sees this question and they just freeze. They're like, oh my gosh, I can never do this question. You absolutely can. Growth mindset, people. We can all do it. Take it slow. Think of it this way. Just think of it as just this question divided by the bottom part, that question. So really, you have 3 separate questions, right? That's all it is. And this big line is just a dividing. So you have basically this question, and then you're just going to divide both of them. That's all you're going to do. And we can do that. I know you can do that. So deal with the top first. So I'm going to deal with the top first. Let's deal with this one. What would you want to do first? Add, subtract, multiply, or do exponents? What was that? You want to do exponents? Absolutely you do. So 5 plus 3, take away 1, times 7 to the power of 2 is 14, right? Right? No, it's not. It's 49. It's 49. Don't do the common kid mistake. So there we go. And now a lot of students will want to do this. They'll want to do this kind of stuff right now because they get super excited because it's easy. Remember, we need to do our multiplying here. So we're going to make this a negative 49. Now we're going to go left to right. So we get 8 minus 49. What an ugly number. 8 minus 49. I think that will give me negative 41. And that's your denominator. Look, we're halfway done. Now we're going to go and do this part right here. This is child's play for you now. Double negative becomes positive. We have a negative number and a positive number. Ask yourself, is there more negatives or positives? You know there's more negatives. So your answer is going to be negative, and it's going to be a negative 2. So we have this, and we have this. And basically what it looks like is, where's a good color? There you go. It looks like this. Negative 41 over negative 2. Sweet. Now, things to point out for this one. You have a negative over a negative. So you need to clear that up. You need to clear this up. Negative over a negative is going to lead to a positive. And then you're going to be left with 41 over 2. Now, depending on your math teacher, you can leave your answer like that. If you have Mr. Douglas as your math teacher, you leave your answer like that. Improper fractions are the way to go. However, some teachers will want you to go and make that into a, what do you call those things, like a mixed number? Ugh, a mixed number. And I think that becomes 20 and a half. Yeah, it becomes 20 and a half. Whichever, I prefer that. If you do mixed numbers, it makes me sad, right? So why make your math teacher cry? Well, I make him cry. Don't do that, please. So you've seen quite a bit of different examples. Get lots of practice in these ones, and you will be an order of operations superstar. Thanks for tuning in, everybody. Go and subscribe down below, and until next time, have a great day.